Hi all, welcome to SK Data Diaries. Myself Senthil, I'm working with the MNC as a data engineer. In our previous video, we talked about higher level and lower level APIs, and we understood that how higher level API make our job simpler by using schemas and making Spark more performant. Going forward, we are going to use higher level APIs only. Being said that, understanding data frames and Spark SQL is crucial. There is one more higher level API called datasets, which is linked with Scala and Java. Since we are going to use Python, you can explore datasets on your own. It is so crucial to understand that Spark SQL and data frames are interchangeable. We can change from data frame to Spark SQL and Spark SQL to data frame very easily. That is the core topic of today's video. We will see how we are changing from data frame to Spark SQL. Lot of people with SQL background trying to fit into data engineering. This video especially for the SQL lovers, not only learners, even businesses also moving from traditional SQL transformation to modern data frame transformation to leverage the distributed computing process. Without further ado, let's get into action. So in our previous video, we discussed how to create data frame. Let us see small recap now. Spark keyword is the entry to the Spark engine. By using a read keyword, we are telling that Spark engine need to read the file. By using .csv, we are telling that the file format, and we provided the file path where the file is residing. Dot option is the optional keyword. By using this, we can provide additional information to Spark. Here I used header equal to true and info schema equal to true, which mean I am telling the Spark engine that my file have a header and Spark engine need to infer the schema. By executing this cell, I created a data frame called data frame. Here you can see I provided the data frame name. Now data frame got created. Let's see what is there inside our data frame. By executing .display keyword, it will visualize our data frame. Here you can see our data frame have multiple columns and 8523 rows. Let's see the schema of our data frame. By providing .print schema keyword, we can see the schema of our data frame. Here you can see item identifier is a string, weight is a double, and so on so forth. Now we are having our data frame. How to create a table. In our previous video, we discussed how to create managed and external tables. For demo purpose, I'm going to create managed table. Let's recall how to create a managed table. For creating a managed table, we have to create a temp view by using our data frame. Here, I created a temp view called supermarket sales. By using .create or replace temp view keyword, we can create a temp view. Then we have to create a table and then insert the data from this temp view into our table. I created a table called sale underscore sm underscore table. For creating table, we have to provide column name and data type. By using print schema, we know the data type. We can provide the same data type here while creating a table. Executing this cell will create a table. After creating a table, I am inserting a data into a table by using temp view. If you remember, supermarket sales is our temp view. I'm inserting data into our sales underscore sm underscore table by using insert into keyword. Here you can notice I used percentage SQL, which means I am telling a Spark engine that I am executing SQL statement. Instead of providing this, you can use the interface and tell Spark that you are using SQL. both works in the same way. For example, I'm clearing this and use this one to inform Spark engine that I'm using SQL. If I execute, this will result in the same. So you can use the interface or use person SQL directly here. As of now, we have created a data frame and SQL table. Our data frame name is data frame itself and our table name is sale underscore ism underscore table. Let me visually show you the data frame and the table which we are having. By using dot display keyword, we can visually see our data frame. Let me execute the cell. This will show the data frame which we are having. Here you can see multiple columns with 8523 rows. If I run this select star from our table name, this will give me the same output which we are having. Here you can see it is showing 8523 rows as same as our data frame. Now you are clear that we are having a data frame and table which exactly looks like same. Now we will see how to convert our SQL code into PySpark code. First we will see our SQL code. Our SQL code is saying select this column from our table where item MRP is greater than 250. Let me execute the cell. This will give us the output of 444 rows. People who know SQL, you understand this query very well. Here we are filtering a data where item MRP is greater than 250 and we are seeing only column called item identifier, item MRP and outlet type. Let me show you how to convert this exact query into PySpark code. When it comes to PySpark, we have to mention our table name first. In our case, data frame name. For example, our data frame name itself, data frame. Then we have to define our var class. Here I wrote dot filter, which is the equivalent keyword to our var class. Syntax is available all over the internet, but the logic building is necessary here. Inside filter, I provided the condition where item MRP is greater than 250. Here you can see I mention our data frame name and then column name. This is how we provide our filter condition in PySpark code. Let's rewrite our select statement. In select statement, we provided only three columns. So for doing that, we have to use dot select keyword and provide all the necessary column inside the select keyword. You can see that I assign this entire code to different data frame. I inform you this in earlier video also. For capturing the changes, we have to assign this to new data frame. That is what I did here. I assign this entire transformation to new data frame called filter underscore data frame. Now let me execute this code and see the output. Here you can see it gave us 444 rows, exactly same like our SQL code. By using this, you must have a basic understanding how to transfer your SQL code into PySpark code. Let's see bit advanced code than this. In this code, I cover grouping and aggregation. The intent of this code is I want to group the data by outlet location type and see how many items sold and total sum of the amount. This query is straightforward. I'm grouping by outlet location type and taking the count of item identifier and summing item MRP. Let's run this code and see the output. Here you can see I used alias as number of items sold for count and sold amount for sum of item MRP. This gave us the output of aggregated data here. Let's see how to convert this code into PySpark code. As I said earlier, we have to start with our table. In case of a data frame, we have to start with our data frame name and then we have to provide our logic. Here, our main logic is group by. In data frame also, we use dot group by keyword only. I mentioned dot group by and provided the column name on which it should be get grouped. Then we have to provide our aggregation logic, which is count and sum. In data frame, we have to explicitly mention that we are doing aggregation. For that, we use dot aggregation keyword. Inside dot aggregation, we can use various aggregation function like count and sum. Let's see the further changes. Here, we provided count of column name. Same goes to data frame also. We have to provide dot count of a data frame. Here we use space and then alias, but in data frame we can't use space anywhere in between. It should be linked together. For linking, we use dot everywhere. Here you can see a data frame dot group by dot aggregate dot count. So for count, we have to use dot count and column name. So for aliasing, we have to use dot alias keyword and the alias name. Up to now, we build our count query. Let's focus on our sum query. For sum, we provide a dot sum and column name. For aliasing, we use dot alias keyword. Let me execute the query and how the result look like. The result exactly looks like the same as our SQL query. You can see it gave us a 3 line of output and showing the same value. With this example, we understood that we can transfer any of our Spark SQL query into PySpark query. Keep practicing this, transferring a SQL query into PySpark query. Start with the basic query and keep on progressing until you start writing complex PySpark code without seeking help from my internet. This activity will be more helpful for your future data engineer career as well cracking the data engineering interviews as well. People who don't know SQL, I highly recommend to learn SQL first and then come to PySpark code. In that way, you will build the strong basement and progress further. In today's video, we cover how to convert any SQL code into PySpark code. With that note, I'm ending today's video. Please don't forget to subscribe the channel and press the bell icon. I hope I added some value. Keep learning. Happy learning. Thank you.